All right, I wanted to start with a question. How many people in the room are engineers? Hands up. Any kind of engineer. Okay, maybe about 25%. How many of those are building engineers? Okay, maybe about 3 or 4 people. So I got here on Friday, and I met a lot of architects and a lot of contractors, but not many engineers, building engineers. And I was actually a bit surprised because a lot of construction and a lot of creating buildings is about engineering and creating efficient details and creating buildable buildings. Contractors will know the minute they get a silly detail on site, it's costing them time and money. And anyway, so me and Chris here are both engineers. I'm a structural engineer by training. I actually work for a design build company, builds and designs and engineers timber structures, but and Chris is a software engineer. But what we were thinking is, why don't we stand up and do a little bit about our trade, show what the engineering side of this whole web revolution might look like. So, next slide there. Oh, is that you? All right, wow, that's a big screen. Yeah, so in engineering and also in architecture, you need to do a lot of analysis in your building. You do building energy, thermal modeling, you do structural analysis, all sorts of different types of modeling. And one thing that often gets lost, these analyses can be very complex and take a lot of time to run. And there's no real nice ways of taking these different analyses at different points in time, comparing them, and really creating snapshots in time. The analysis packages that are out there generally only allow you to look at one particular instance in time. So our idea was to basically take results from many of these different analysis packages, chuck them on the web, use WebGL to view these things in 3D, and in that way, it basically enable various things. If you hit next slide. All right, so the first pain point we identified is there's many analysis packages. Next. If you just skip through the next few slides, it's just showing some of the different, there's many different packages that can be used for analysis. And just go back one slide. Yeah. This slide just shows, just from a structural engineering point of view, just maybe a third of the packages that are out there. And you can imagine when different engineers are trying to talk to each other or compare results or compare what they do, it's very difficult because there's no unified file format for like translating and comparing what this data or these models actually look like. The green grasshopper in the center, some of you may have heard of it, it's similar to Dynamo for Revit, but it's a visual programming language desktop based that allows you to, in some respects, connect these packages together. The only problem with that is that's done here on your computer, on your screen. No one else can really see it unless they have all the same software and all the same stuff you've written. So our idea was to kind of make that a bit more agnostic. Just next couple of slides. And basically put that on the web. The second pain point we identified is that often you're doing parameter studies. So you're looking at, okay, what if I make this building a little bit bigger or a bit smaller, or I change this column spacing, all this kind of stuff. And so you're wanting to know, how do these different changes in parameters impact the building? And you don't want to just see it one parameter at a time. You want to be able to see them all together and scroll through the different options, as it were, for your building. Next slide. Just go forward a couple. And another thing is, how do you look at changes in time? So this is looking at, for example, seismic analysis, where you're looking at a building moving. How do you capture that, and how do you show that to people who need to see it, to clients, or to especially here in the West Coast, seismic engineering is very important. So next. So people who are having these problems, primarily engineers, but also the people who we're trying to communicate these analyses to, architects and also building officials. Building, it's very important that buildings meet building code, and showing these analysis results to them is very important. Next slide. So one thing that engineers spend a lot of time doing is running these analyses, making printouts or whatever it is you do to capture what these the states of these different analyses, and and then kind of document their design process. But there's no real nice and easy way other than just saving multiple copies of same files to actually go back and view the state of these different analyses through the project. So, next. So as I said before, you can use Grasshopper in some respect to kind of use a slider and scrub through different solutions. But of course, not all analysis that you run for buildings, like, for example, daylighting analysis or thermal analysis runs instantaneously like that, so you can actually scrub through it. A lot of it takes a lot of time, takes maybe even hours to run. And so the idea here is to create a platform on the web which you can basically display your pre-baked analysis runs in. Next. So this is then just having a look at this here. So what we've done is using 3.js and socket.io basically connect an analysis package, which in this case happens to be structural analysis inside Grasshopper, into the web. Now, what you're seeing here is different iterations of this particular grid shell model and different states, different configurations, different density of grid, different size of elements, different force states in the elements. And all those solutions there, I literally, just while I was down here, pushed to the web. So this is stored in a web database. And so anybody who's running that software can literally push their analysis results from not just Grasshopper, but from any structural analysis package or building energy analysis package. I mean, we've used a structural example here, but this could very well be results of shadow analysis for a building or anything like that. And so the idea is that you can kind of scroll through your solutions or even display the solutions side by side, all your results, to enable a much more robust design strategy. And also you can provide a permalink to a design at a certain point in time, so that it captures your thinking at that point in time, and you can go back to it at any point in the future. You can reference it in whatever calculations you might do, and provides a way of capturing it. So I mentioned briefly the tech stack we did. So this was all done in the last day, so right from scratch. Chris here managed to, you want to talk about it?
Yeah, sure. So there's two parts to it. There's one on the client side that looks at files that are exported by Grasshopper. It'll just look at all these files it's told to look at. If it sees this change, it'll post it to a service running Flask. It's a web development thing in Python. That's up on Heroku right now. And once it sees that, it will process that comma separated file and then inject it into, by using WebSockets, into the actual running display up there. So this is kind of an example right here where, actually we can try and export a file if you want. We'll try a live demo on this one here.
So on my computer, I've got Grasshopper running, and I could change, for example, the density of the grid.
Yeah, these are previous ones. Oh my God, it worked.
There you go. Worked. So I changed the density of my grid, storing it straight to the server.
So what's nice about this is that I can view it on my browser. There's nothing special. It's HTML5. But he's got like well, I guess it's not really high-end, but it's whatever it is.
It's easy, yeah.
And I don't have that. So it's nice for him to change it. Like he can change it again. Now we know it's going to work. So you should see it auto-magically update. There we go. He put some more meshes on there. So that's about it. All the code we have up on GitHub. It's open source. And 3JS was the web.
Yeah, so the key here is that previewing these analysis results is not using a custom plugin which is written for a particular piece of analysis software. All this front end is doing is parsing a bunch of CSV files, comma separated values. So this analysis could be coming from any software you like. It doesn't matter, it's completely agnostic. And all you need to do is write, slightly different front end code to parse that data. Maybe just hit next slide. Yeah, this is kind of what we've just been talking about, allowing, creating basically a solution agglomerator, as I was thinking of it, which allows you to really explore the solution space. Next slide. Yeah, one of the things that really struck me was that we were able to get this up and running in a day right from ground zero. Now, even just a year or two ago, this wouldn't have been possible. With open source libraries that are out there nowadays, you can really hack something together really, really quickly. And so there's no need to be tied to vendor-specific solutions necessarily, which won't necessarily talk to your particular package. You can really actually just hack your own thing, put this up on the web, open source, and anybody else can write their own link to their particular analysis package. Next slide. And yeah, that's it. Check it out on GitHub and let us know what you think. Add to it, please.